How's it going?
Great.
So far, so good.
Awesome. Ready to roll? All right. Can everyone see my screen? You can hear me fine, I guess.
That's fantastic.
Okay, let's get started. So thanks for inviting me here to talk about the future of computing with spatial computing and the metaverse and quantum computing. So I take up this challenge to explain these two complex topics in a short time. And you might say, what does it actually have in common? Like spatial computing, quantum computing, these are two distinct topics, if you will, but they have one thing in common. They will change computing forever, and they will also change how we as humans interact with computers. And so first of all, we're going to focus on the spatial computing part, and I will introduce the terminology, and then we will talk about various flavors and implementations, and I will show you a lot of practical use cases that we developed. And then in the second part, of course, we will talk about quantum computing. I will also give an introduction to the topic, tell you about the basics that you need to understand in order to actually know how a quantum computer works. But then also we're going to dive more into the key areas, and I will show you applied use cases with quantum computing and things that are already doable today. My name is Rene, like it was said. I work at Valorem Reply, and I'm also leading the spatial computing community of practice at Reply. Additionally, I'm Microsoft Regional Director and Most Valuable Professional MVP for mixed reality as well as quantum computing. These are awards that Microsoft provides to independent experts that share the knowledge. So I do a lot of speeches, but also if you connect with me on LinkedIn and Twitter and so on, you will see me constantly sharing stuff here and doing thought leadership. All right, well, let's get started with spatial computing. And like I said, we need to explain this a little bit. And in order to do this, we need to go back a little bit in time. And a few of you might remember the 1990s when a lot of folks got their first personal computer at home. And it really changed the game once these computers became connected through the internet. And once the knowledge sharing happened through Web 2.0, with everyone can write blogs or microblogging and so on, and it really gave a lot of push to information and knowledge sharing in general. After personal computing, mobile computing came along with like these kind of devices, especially smartphones. And here on the slide, I have a BlackBerry, which was one of the first smartphones ever, but definitely the real kickoff was in 2007 when the first iPhone with touch input came out. And it made computing not only mobile, so that we don't have the big desktop personal computers under our desk now in our pockets, but also it brings us a lot of computational power plus sensors these devices have built in, which can provide us contextual information. And think about GPS, like geo-positioning systems. And so the device can know where it is in the world and can provide you contextual information. Simplest use case is maps, of course, right? But now, after personal computing and mobile computing, we're entering the so-called spatial computing age, where we have so-called intelligent edge devices that can even further sense the world around us to a higher degree. And the form factor actually doesn't matter so much. Like here on the slide, you see the person wearing a HoloLens, a head-mounted device where you have semi-transparent lenses where you can see through and see augmentation, see augmented reality. Basically, while still seeing the real world, these semi-transparent lenses allow you to project information in it. But it could also be just a mobile phone, right? Like these mobile phones, they have good cameras, and it doesn't even need to be a depth camera or a 3D camera in these phones. A normal color RGB camera is good enough, because that's why these are intelligent edge devices, because they have intelligent built in, namely computer vision AI. And with this technology, they can sense the world around you to a high degree. And same is also possible with virtual reality devices like the Quest I have here. They have these cameras for tracking the device itself in the room. And so the device also knows where it is in the room. And these are spatial computing capabilities, right? Of course, a user experience is way different if you develop a solution for mobile phone-based augmented reality experience, or if you do it for head-mounted device like a HoloLens or virtual reality with the Quest. Of course, these are different user experiences you build. But from the technology standpoint, they have one thing in common. All of these are spatial computing devices. They are spatially aware and they can sense the world around you. So I'm not here in the synthwave kind of a metaverse, as you can see in my virtual background. Of course, I'm in a real room. And so these devices can sense, okay, there's a floor below me, there's a ceiling, there's a wall here and there, and so on. And so this information can then be used more precisely as part of the computation. And that allows us to very precisely locate these devices and bring in contextual information. And I will show you a bunch of examples how this can be used for providing some interesting use cases with spatial computing and the real world around us. And you might ask, well, who has such a device, right? Well, a lot of folks already have devices in their pocket that support these advanced capabilities, these spatial computing capabilities. On iOS, like iPhones, you have ARKit. On Android devices, you have AR Core. And pretty much every new device that came out in the last couple of years has these advanced computer vision capabilities where they can locate themselves very precisely based on computer vision and not just based on GPS. So these devices can support visual positioning, but more about this later. And so then you might ask, how does the VR market actually look like? And the latest statistics I found is about the Meta Quest 2, which I was holding up here, and you can also see it on the slide. They sold almost 15 million of these devices, which looks on the chart tiny compared to the mobile phone market. But just imagine 15 million units is quite a bit, actually, if you consider how fresh the market is. And it's a growing ecosystem, and the revenue is also pretty good if you're developing apps and games. Approximately, they spent 1.5 million US dollars on apps and games in the Quest store, which means of these 50 million people, approximately a user spends $100 on average for buying apps or games in the Quest store, which is really good if you're doing mobile development. The margin is shrinking, and this is a new market, basically. But again, like I said, we got to talk about the metaverse these days, and I will give you an overview, and we will talk about various flavors of it, like virtual ones, but also the real world one. And I'm sure you have heard many definitions about the metaverse also in the series here at BurdaForward. But I like the definition of Gartner, how they define the metaverse, which is a collective shared space where you have a convergence of virtual and also physically. And so basically you combine the physical world with the virtual world. And that is an important part, because otherwise you just have another online game where you just have these virtual worlds, right? And another important attribute is it needs to be device independent, which means I can use these metaverse experiences with whatever device. I should be able to use it with a mobile phone, with a desktop computer, or of course, if I want to get the full immersion with a virtual reality or another headset. And it needs to be persistent, right? So if I, for example, take this coffee cup here and I put it here on my table, and then I come back to this virtual world with the coffee cup 5 days later or whatever, it still needs to be there. And this is a key feature. And this will also require a lot of computational power and storage. And this will be a big challenge to actually make this vision a reality, that we can also have this true persistence, right? You might hear a lot of definitions, when they talk about the metaverse, and they just use it as an analogy for basically augmented or virtual reality headsets. But it's better to look at the broader picture, basically, that you would say it's the next generation of the internet. It's the immersive internet. And if someone asks you, hey, can you give me just one sentence, what is the metaverse? Simply put, the metaverse is the new immersive internet, but you can go into it with virtual reality, or it can come to you with augmented reality. That's as simple as it can get. Gartner is also saying a quarter of the population will spend at least 1 hour per day in the metaverse in 4 years. We'll see if this turns out to be true, but definitely a lot of folks are pretty bullish on that. And if you include like online games, large online games, which are first versions of metaverse experiences, it might actually become true. McKinsey is saying 5 trillion US dollar opportunity by 2030. And they're also saying the metaverse is too big to be ignored for companies. And I keep on using this kind of analogy, right? If a company doesn't have a metaverse present in 2030, it might be the same case like if a company doesn't have a website today, right? And you might not engage to do business with them, because if you think about yourself, right, when you need to get a service worker or some kind of service, you typically go to a search engine, search for it, find the website, look at it up, and then you make a decision. And if the company doesn't have a website, you're probably not going to engage with them. And if this kind of prediction is true, the same will be applied to the metaverse, right? So if a company doesn't have a metaverse presence by 2030, they might not be relevant anymore. So what are some different kind of platforms? And these pure virtual metaverse platforms where you're fully inside of a virtual world, you have many of those on the market at the moment. And I like this chart here where we can group and categorize this a little bit. So as you can see here on the slide, there's many different metaverse platforms on the market at the moment. And you might rather say it's a multiverse, like multiple metaverse platforms. And you can categorize them by the ones that are using a blockchain technology, like decentralized platforms. And you can see these are the bottom ones here. And then on the top, these are no blockchain. And then on the right hand, you have VR-enabled platforms and those that don't use virtual reality. And if you categorize them, and if you look at the big players like Horizon from Meta or Altspace or VRChat, these are all centralized. Like these are all centralized platforms. If you look at the blockchain-based ones, to name Decentraland, Sandbox, Sonium Spaces, they are also gaining a lot of momentum, and they are built on the promise of the blockchain, where you can basically do asset transfer on the blockchain. Think about, you have an avatar, you want to buy an accessoire for this. This is a transaction on the blockchain. This kind of stuff is enabled with these decentralized platforms. But as you can see, it's this wild market with a lot of different players at the moment, and you have the big companies, you have the startups, all of them are building their own platforms. And like I said, it's kind of a multiverse. And that's why I'm pretty excited and bullish on this new Metaverse Standards Forum, which you can see the logo here. This is PowerPoint 3D, by the way. Like this is a 3D logo of the Metaverse Standards Forum. So what is the Metaverse Standards Forum? It's an initiative by the Kronos Group, which you might have heard about from OpenGL or OpenXR and other open graphics standards. And they are working on these standardization of an open metaverse, and most importantly, the interoperability, so that you can basically work together. And it doesn't matter if, for example, Ulf is in Horizon Worlds and I'm in Altspace. Under the hood, we can be in these platforms, but there should be an overlaying interop layer on top of this, where we can communicate with each other in a common way, right? Even if we're in different worlds under the hood, if in different metaverse platforms, if the true vision of the metaverse should become true, we need an interoperability standard. And I'm glad there's the Metaverse Standards Forum. Of course, we are part of this, but also the big players like NVIDIA, Unreal, Unity, Microsoft, Google, Meta, you name them all, they're also all part of this Metaverse Standards Forum initiative. And so this is a very important piece to actually make the true vision a reality, that we have open interoperability between these different platforms. To give you a few examples, I'm sure if you have heard about them before, but the big players like Meta, of course, are pretty active in that space. They are looking into creating the new version of the next version of social media, of course. But they also have really interesting collaboration and enterprise metaverse platforms like Workrooms, which I'm going to show a little bit later. And then also this Horizon Worlds, which is an open world building kind of a metaverse platform, like this more for the public. And the cool part about it is actually a low code, no code platform, where you can also, as you can see on the screenshot, design your world and add some interactions for it and do some pretty cool stuff with that. Microsoft is currently working on Altspace VR, but of course also in Mesh. We'll talk about this a little bit later. But Altspace VR is a pretty successful platform, and you can use it for private, small group gatherings. Like for this, we could also meet in Altspace, of course. But you can also support very large events, like up to 10,000 of people. And Microsoft has been doing this also for their own conferences. So here's a quick video from the Ignite keynote, and you see all the people are joined as avatars in the platform, and the presenter, the speaker here, Kipman, he is shown as a video, And so we can get these nice holoportation stuff in it, where not everyone has to be an avatar, but the presenter, for example, can be a hologram or a 2D or 3-dimensional video, which feels, of course, much, much more immersive once you wear a VR headset. But the good part is all of these platforms are able to be used on 2D devices like desktop, PC, or mobile. Enterprise metaverse is also an interesting topic in terms of collaboration. And I can show you some examples here where we have been using this, like this one here, where we have been using Horizon Workrooms as part of a team meeting here. This is just a quick demo. We had around 13 people all joined with a virtual reality headset on. And as you can see, this is recorded from my personal perspective. And I can also share the screen. So what you see, there's a little Excel sheet shared from my computer. So I sit in front of my computer while wearing this headset on my head. So I don't really see my computer, but I can share it inside of Workrooms. So I can still use my computer mouse. The cool part is actually you can also map certain keyboards in Workrooms. And so you can actually type on your real keyboards, on your real keyboard on your desk, and you map it in virtual reality. So this is pretty good, but just works with a few keyboards. Why is this useful? I often get asked, yeah, well, this is a nice gimmick, but why would I use this? Well, I can tell you feel much more connected and much more immersed. Like you can see, we can even do high fives because we have hand tracking with these devices. And so you have this great 3D stereo vision where you can see 3-dimensional in stereo 3D, but you also have spatial audio or spatial sound. And which means I can hear, for example, if someone is talking over there, I know exactly where the person is talking and I can, turn my head and look at them. And you feel much more connected with the team. We have a distributed team in Germany, Italy, the US. And it's much better than just doing a Teams or Zoom meeting where you have these small post-stamp videos. Here, if you put on this device, full field of view, full immersion, and also no real distractions, right? Like if you put on this headset, it's much harder than to switch, do an alt tab and go into, I don't know, do emails or whatever, right? Like you get easily distracted in these meetings. But if you're doing these immersive meetings, like Workrooms, for example, you're much more focused. And I can remember also much better from these meetings. You might ask, why is this the case? Well, there's actually real science behind it. Our human brains work actually spatially, and you can remember things more better if they're spatial. And we get with these solutions, we get spatial vision, we get stereo 3D vision plus spatial sound, and that helps a lot to, memorize it much better. Of course, you wouldn't do this the whole day for all meetings. That's a little bit too much. But for certain things like these kind of team gatherings, if you have distributed teams, they provide a benefit compared to the online meetings for sure. Although you see the people as avatars, right? Well, here's another platform you might hear about, Spatial IO. Pretty much similar features. They have a different avatar system, which they finally changed a little bit because was always a little bit awkward because the avatars they have in there sometimes look a little bit weird, I have to say, because they actually show the arms, but look at this, if the tracking is wrong, like the avatar can really look a little bit weird. You can also do these kind of things in Altspace. VR from Microsoft. You can also do these kind of team meetings. Here's another where we did this together as a team gathering. And well, what we're all, of course, waiting for is Mesh for Teams, which Microsoft is heavily working on. Mesh for Teams will be the gateway into the metaverse because Mesh for Teams will come to every Teams user. And they currently have 270 million users that are already using Teams. And they get an easy entry point into these metaverse and hybrid work solutions, which are more immersive with these kind of collaboration rooms. But also you can have public events and do a lot of things. And you can just do it on your desktop PC client. But quickly you might find out, well, just watching it 2D on a screen doesn't give me a benefit. And you might switch to one of these headsets. And Microsoft just last week at the Meta Connect event, they announced a partnership with Meta. They will not only bring Mesh for Teams to the Meta Quest 2 and the Meta Quest Pro, but they will also bring Microsoft 365 to these platforms. Namely, applications like Word, PowerPoint, Excel, and so on will be available on these platforms. And you might wonder, why would I actually use this? Like, why would I use and write a text in Word, not on my computer, but in a VR headset? Well, you see the picture here, right? You don't need monitors. And just think about if you're traveling, if you're on the road, especially with the devices like the Quest Pro, which has a very high resolution display, you can actually get a very large display right in front of you wherever you are. If you're in a plane, if you're on the train, it might look awkward, if other people see you wearing this headset, they will get used to it. But the important part is you have this productivity everywhere you want to go. What they also announced at the Microsoft Ignite event a day later than Meta Connect was mesh avatars. You can basically now, apply for a private preview of this, and it will allow you to, well, first of all, design your avatar, which will be used in these immersive meetings, in these mesh Teams meetings later on. But you can also use it just inside of Teams. Instead of a webcam, you can be represented as an avatar and have a lot of flexibility how you want to look like. And you might just be another person and you can be your true self, right? Which is an interesting thing to actually look at if you see it from that perspective, right? You can represent your true self. You also don't need to turn on the webcam, but it's much better than having the webcam off, I guess. So much about this. I mentioned a few things around spatial computing and the real world, and this is what I call, and actually also Niantic and a few others are calling the real world metaverse. And so what is that? I mentioned to you, we have these devices, again, could be head-mounted devices, but also mobile phones, right? If I use this phone and scan around here, it creates a spatial map, a spatial mapping of my environment. And if I do this here and you do this over there, and a lot of other people do this all over the place, what we get is we get a digital twin of the world. And if we overlay this on our real physical world, what we get is this digital twin or the digital content layer on top of our world with a machine-readable computer vision map. And this allows us to anchor and pinpoint certain experiences at specific locations. And here's a quick example from my hometown, Dresden, where I put an old video that was taken before the war in 1946 and put this in the actual location where it is currently. And if you see the Sophia Church there, the two church towers, that was, for example, not rebuilt after the war. And so if I go around this portal, this video, basically, you can see it looks quite different. The content doesn't matter so much here. What I want to tell you is basically with this technology, and this is built with Microsoft's Azure Spatial Anchors, I can pin a specific experience. In this case, it's a video, but it could also be a photo. It could be 3D models, whatever it is. I can pinpoint this at any location in the physical real world, and I don't need QR codes. I don't need any markers, and I also don't need any GPS. So this is based on computer vision. So again, the experience would be you go to this place with your smartphone or with a HoloLens, you scan the place a little bit, takes a few seconds, and then it will recognize, okay, this is the location where Rene left this video, and then it will recognize this and load this content exactly at the position. And we're talking about a precision here in the 5 to 10 centimeter range. So GPS would be way too unprecise. But with VPS, with visual positioning systems based on this computer vision, we can actually get more precision, and it will also work indoors. And so this is with I built this with Azure Spatial Anchors. Other players are also working in this field, like Snap has this location service. And here you can see a demo video, a rather recent one, where they're also showing old pictures. I wonder where they got the inspiration from, because like the stuff I did was like 2 years ago with Azure Spatial Anchors. But you can see all of these big players are working on similar experiences. And Niantic as well. So Niantic is probably not so much known from the company name, but you might have heard about Pokemon Go and Harry Potter and a few other of these geolocation-based games. This is all built by Niantic.
Kindergarten hat mich gerade angerufen und gesagt, Ihr Sohn ist jetzt aufgewacht, er ist abholbereit. Dabei ist man nun gar nicht im Kindergarten.
I guess there's someone unmuted. Would you mind muting yourself in the Teams window? Because I heard something about kindergarten and things like this. I mean, take care of your kids. That's important. But please mute yourself. That would be great. So what I wanted to say, Niantic also has a lot of user data actually from Pokemon Go. So players could opt in to actually create and capture the world around them. And so what Niantic has is now this VPS, which is a visual positioning system of certain locations in the world, where you can now place content very precisely, anchor content very precisely. And guess what? Google is doing a similar thing. Google has AR Core Geospatial API. And what they're doing is they're using the Street View data they captured through 15 years of Street View and also satellite imagery data. And they're extracting these feature points. So these are the blue dots you see here. We call them in computer vision feature points. And if you take all of these different pictures and videos and you match these kind of feature points together, what you get in the end is a point cloud or a 3D localization map of all the places where they have Street View images. And what I get with this is a very precise device localization map. And so you can go to a place, like I said, for the example, I use my smartphone, just go to a place, scan this a little bit, so hold it on the buildings, so it will recognize where it is. I can put an experience there, like a little game or navigation, a lot of examples. And then another person comes a few days later, they come with their own device, just scan the place a little bit, and they can load the exact experience, and they can see it very precisely at the same location. So really interesting stuff. And like you see, all the big players are working on this. Another interesting piece here is, of course, the kind of the real world robotic metaverse, as we call it. And so we can, for example, use also robots in the play here, because these are also spatial computing devices. What you see here in this demo is a 3D scan, obviously, of a building. It's one of the reply offices in Italy. And where you look at the video and see my cursor there, this is where we had one of these Boston Spot Dynamic RoboDogs, which has a LiDAR laser scanner mounted on the back. So as you saw, the robot with the laser scanner walked around the building and did 3D scans. And in the end, all of this was merged together, and we get a 1 billion points point cloud. Huge points, but also very impressive how precise it is. You have to imagine the robot is a meter high or so with the laser scanner, and it can still capture all the small details and branches, like in the tree you can see here. I guess the video compression is adding a lot of noise to it, but if you see it with your own eyes, it's very precisely captured. So we have 1 billion points. It's very tough to actually visualize this with a mobile device, but we can use a technology called remote rendering. In this case, I'm using Azure Remote Rendering to actually visualize this 3D scan on top of a HoloLens. And the idea behind this, and this is also where we're working with clients, is to actually do 3D scans, do 3D captures of certain places. And then, like, let's say 6 months later, you come to the same place, you take the old 3D scan, put on the HoloLens, and overlay the 3D scans from 6 months ago on top of the actual current situation, and you can compare and see changes there. Remote rendering is a really interesting technology in general. The remote rendering capabilities allow you to use very cheap client devices. In this case, we're just using an Android smartphone, which is not very powerful, like an old Android phone, not very powerful GPU. But what you also see here, we're visualizing in augmented reality, real-time ray traced, well, it's a BMW M7, with high details. And again, this is only enabled with remote rendering, which means the device, could be headset, but also mobile phone, is giving the position and the rotation information back to a server or to a computer, which has a very powerful graphics card. Then it renders the scenery there and streams it back to the client device. So this is basically streaming. You need good internet, of course, but these days this is really not a big problem, and it works even with 4G. But of course, 5G is even better. But look at this. We have real-time ray tracing. Here you can see the reflections. We have real-time ray tracing on the mobile phone, thanks to remotely rendering this. And we can have some really high-end kind of experiences there. If you want to learn more about the whole stuff around the metaverse, I would recommend to check out our report we did, which is called Metaverse Disentangling the Value from the Hype. And with this, we actually used real signals from true signals from expert blogs, news sites, patent fillings, scientific publications, and break down the metaverse in tangible pieces and are disentangling the value from the hype. So if you scan the QR code, you can actually download it right here. Otherwise, just go to reply.com and click on the Metaverse section, and you will find this report as well. Additionally, I'm also doing a video podcast, which is called Meta Minutes. And in Meta Minutes, I invite expert guests, and I typically ask them 3 questions about a certain topic of the Metaverse, and we discuss those in short pieces, 20 minutes, typically 15, 20, 25 minutes, but not much longer, to actually make these consumable, for example, during lunch. And like I said, it's a video podcast, so you can watch it, but we also have it in all these podcast platforms. You can search for Valorem Voices, or just look it up on Google, Meta Minutes. You can also find it on YouTube and so on. And like I said, it's all about the Metaverse. And of course, some of these episodes I recorded actually inside of the Metaverse. So we have a custom world here, and this is my guest Niels, and I had an interview with him inside of the Metaverse platforms, and we were talking about virtual presence and digital humans, which is an important part of the Metaverse experiences. All right, so let's talk about quantum computing without a break. We're going to talk about quantum computing. Like I said, these are quite distinct topics, but quantum computing might actually be required to make the true vision of the metaverse a reality, because we need huge computational power, actually, like I said, for persistence and a lot of other things, and running simulations. You need a lot of computational power, and you might actually not have that right now. So quantum computers might be a key enabler. Also think about true randomness. Like with quantum, you can actually get true randomness, and this might also be required for this. So I think there is actually quite an overlap if we think about spatial computing and metaverse experiences that will probably require some of the computational power quantum computing is going to offer us. So what is quantum computing actually? Well, first of all, it's probably one of the most transformative, or, well, I don't like the word, but disruptive technologies we will see in the 21st century. Right now, we're, in terms of the hardware, we are more in a kind of a stage that you can compare with the mainframe area in the last century. Very huge computers, quantum computers that fill a whole room with super crazy technology involved, but they are not practical usable in the sense that you can have one at home, which might actually also not happen at all. First thing we need to understand is that quantum computers are very good to solve very specific problems. And so a lot of misconception you might hear is, oh yeah, like this, like my smartphone will run with a quantum computer. Probably not, because we need these kind of classical computers still actually also for controlling quantum computing hardware. And again, quantum computers are very well suited for specific problems. For example, solving unsolvable problems we have today, which are much too computational expensive to be able to solve them in polynomial or linear time. And I will show you some examples of this. And so it means we have radical new hardware in terms of these huge quantum computers, but also radical new software. So the way you write your software will be much different than currently software is written. Because what you deal with quantum computers is non-deterministic, which means is if you run a quantum computer and you wait for the calculation, and at the end, the result, you run it once, it might be a little bit different than if you run it 5 times. That's always a little bit different. And so what you need to do is, when you do quantum computing, is you need to repeat this multiple times, like thousands, whatever it is. And then you have this kind of distribution, right? And this is why you know, okay, this is probably the most relevant result from its most probable one. And that's why these are non-deterministic compared to classical computers, like the graphics cards and all the silicon-based chips we are using today. These are, of course, deterministic. And you will see this in a moment, why this is so much different. Quantum computing is based on quantum mechanics, which is a discipline of physics. And quantum mechanics, in the end, describes how the smallest particles we have in our universe behave. So we're talking about atoms or ionized atoms, but also subatomic particles like photons, electrons, and so on. And at the smallest scale, in our universe, certain phenomena occur. One is superposition and the other one is entanglement. And superposition is a specific state you can put one of these elements or one of these particles in. So classical computers, like, again, your computer, your smartphone, and so on, they work with digital information and they work with bits. And a bit can be off or on, 0 or 1. But in quantum computers, we work with qubits. And a qubit can be not just 0 or 1, they can be 0 and 1 also, and they can also be this at the same time, and they can also be any value in between. So this is a crazy concept. You have to wrap your head around it. But if you think about this sphere here, this is called a Bloch sphere. It can be basically, a qubit can be any value on the sphere. And it can also be this at multiple states. And this is the crazy thing about it, but it actually works, and it was proven in experiments that this is in fact the case. And superposition, again, allows us to represent multiple states at once. And it's a really amazing concept. The next piece we need to actually make this computational happen is entanglement. And so we can take one of these qubits, and a qubit as a physical implementation can be one of these particles. So you will see quantum computers on the market that are using ionized atoms. Then you have other quantum computers that are using neutral atoms. Then you have other quantum computers that are using photons, for example, to send information across the wire. And all of these particles can be a qubit. And if, for example, if you have a trapped ion quantum computer, which is using ionized atom as qubits, they basically shoot a bunch of lasers and certain frequencies to actually get a qubit in this kind of a superposition. And we also say excited state. But these days, they can only keep it for a few nanoseconds and not very long in this superposition state. But this is the key piece for actually storing multiple states at the same time. And then you can combine it with another phenomena, which is called entanglement. And entanglement is actually a kind of a piece where you can put multiple qubits together and they become one unit, even if you separate them physically. And the photo you see here on the right-hand side, this is the first photographic proof of entanglement that was done, I think, in 2018 or 2019. Before that, there have been also other experiments that has proven that entanglement is in fact not just a theory. And in fact, I think it was 2 weeks ago or 3 weeks ago, the Nobel Prize in Physics went to 3 persons that are actually had proven entanglement in experiments. And they got a Nobel Prize for this in physics. And so you see, this is very much relevant, and they helped a lot to build the ground for quantum information science and quantum computing. Entanglement, again, you take 2 qubits, put them together, entangle them, right? And if you then separate them physically, like this is what they did here in the experiment with the photographic proof is, they took 2 photons, entangled them together, and then they separated it, sent one in this direction and the other one in this direction. And only one of those got a phase shifting applied. Basically, it means they're rotating the particle. And guess what? They measured both at the ends. And although they were already kilometers apart, both showed the same kind of state change. Like both were rotated the same at the end, although they're physically separated. They were initially entangled, then separated. Then one attribute was changed for one qubit and the other one had the same attribute change. And so this is crazy. Again, Einstein actually called this spooky action at a distance. He was never a firm believer of quantum mechanics, because you have to imagine, like, when these guys were living, like Einstein, Heisenberg, Bloch, Max Planck, you can name all of them, Schrödinger, of course, and a few more. This was around 100 years ago, and it was all just theory. It was all just, theory. But since then, in the 60s and 70s, they have been proven with experiments. This is where the guys actually got the in the 80s, they got the Nobel Prize for these experiments where they actually have proven it. And then we even got the first photographic proof of entanglement just a few years ago. And so we can use these 2 principles, put a qubit in superposition, entangle that. And what we get with this is basically a massive parallel computing that is scaling exponentially. So if we add another qubit, we can solve another crazy exponential problem. And this is very useful because we have specific problems in computer science that are exponentially complex. Bunch of key areas here for quantum computing. I'm just going to quickly go over a few of those. Quantum machine learning is pretty interesting. So you can basically apply a quantum computing in pieces of a neural network, and you can represent the state much better. Quantum optimization, we're also going to talk about this in a moment, and then quantum security. Quantum security is two things. It's an opportunity, but also a threat. The opportunity is for very secure information exchange, which is called quantum key distribution. So we have the two personas here, Alice and Bob. These are classical, security kind of roles. And Alice wants to transmit secure information to Bob. And what they can do is, if they're using a quantum channel, basically a specific quantum connection where they can submit superposition particles through, they can submit a key through this, right, in order to encrypt the information. If you have an intruder in between, like Charlie, the bad guy, he's looking at the key, he's going to steal the key. This is not going to work, because Bob will always know if someone was eavesdropping, if someone was looking at the key before him. And that is an important part, because it's physically impossible that Bob will not know it. Because if you submit it in superposition from A to B, at the end, you always have to measure it. You have to look at it. And this means the superposition state will collapse. And so if Bob receives a collapsed key, he will know that someone looked at it. So what they do is they just repeat this multiple times until they have a secure connection, and then they can just use a classical channel to, encrypt the information and transmit it with each other. This is already happening. We have quantum key distribution backbones in a few different countries, like here in Europe, but also Japan made a big breakthrough with a 600-kilometer long quantum key distribution network. But also China has actually operational now since this summer a satellite. So China has a satellite orbiting Earth where they can transmit quantum keys with the ground stations, right? Pretty interesting. But this is the securest way of transmitting information, uncrackable. Also, true random numbers can be generated with quantum keys. So you see, this is a typical key distribution or random numbers you get with a classical computer, which only can produce actually pseudo-random numbers. And with the quantum computers, I can get true random numbers. But I also mentioned it's a threat. And the threat with quantum security comes in a way where you could say, well, we are going to witness in a few years that our current today's cryptography is breakable. And that's why I always recommend IT companies and basically everyone to look into crypto agility, to make sure they're very agile with their cryptography stuff, that they can quickly swap out certificates, that they can quickly swap out encryption algorithms. Because at one day, Q-Day will happen. Q-Day is the day once we have a quantum advantage. And basically, this means we have a quantum computer that is powerful enough to crack today's cryptography, to break today's cryptography. If you look at internet communication, HTTPS, but also messaging or financial transactions, all of that stuff is happening via security, via encryption cryptography. And typically today, an encryption algorithm called RSA 204080 is the gold standard that's being used mostly. And if you want to break such a key, it will take, with a classical computer, 300 trillion years. Way too much, right? This is the idea actually behind these encryption algorithms. They're using prime numbers. But with an algorithm for quantum computing called Shor's algorithm, we have a way to factorize prime numbers. And if we have a quantum computer that has around 20 million noisy qubits, these RSA 204080 keys can be cracked in 8 hours. Once we have a quantum computer with 4099 stable qubits, you can crack this key in 10 seconds. So basically, this means all today's cryptography will be obsolete at this point. When this happens, no one really knows. Experts are estimating it will take 5 to 40 years. But breakthroughs in technology happen exponentially, so it might actually happen faster than we might think it will happen. Last piece, and then we're going to open for Q&A, is quantum-inspired optimization. We have a lot of these implemented already at Reply, but you can think about that you can, like I said, we have this massive parallel computing, and we can use these quantum algorithms to solve certain specific problems in a shorter amount of time. And you can think about fleet management, material science, but also life sciences, protein folding, and so on, but also financial optimizations like portfolio optimization, Monte Carlo risk analysis, all of that kind of stuff can be done with quantum computing. And you can actually already do this today with quantum-inspired optimization, which means you develop an algorithm as a way you would write it for a quantum computer, but you can already run it on a quantum simulator. And a quantum simulator could be a large array of GPUs or FPGAs, and you can run these simulations basically on top of it, and you get even better results. For example, here's a case we did with one of our clients with Enel in Italy. It's actually one of the largest energy grid providers in the world. And they have 20,000 field service workers that go out every day, visit clients, repair stuff, and they got to plan the schedule for them, right? And this is a tough problem to solve. It's a nonlinear optimization problem. And we developed this MegaCuber algorithm that is much faster, although running on a quantum simulator, and it's saving them 20% time already. And again, think about it. It's a quantum algorithm running on a simulator. If we have a powerful enough quantum computer to run this will just like fly and go through the roof. If you want to learn more, we did also the Albus Quantum channels, published a bunch of papers, and I'm also doing this video series, again, similar to Meta Minutes, but this one is Qbytes, not qubits, but Qbytes, bite-sized pieces of quantum computing, and had 50 episodes so far and talked with experts to make it actually approachable, so they don't need a PhD in quantum physics to actually understand some of that. Well, with that, thank you so much, and open to questions, and thank you.
Wow, thank you, Rene. That was awesome. That was mind-blowing. Thank you so much. Great. I have so much questions in mind, but I will want to open this to the public. So if you have questions, put them up in the chat. I had one when I was following your presentation, you talked about this quantum leap. Does this have anything to do with the Byzantine's generals problem, or is it solved, or is it a complete other thing?
Can you just repeat the question? It was breaking up a little bit.
Sorry, you were referring to the quantum leap and the thing that there's a message which is to be tracked when going from Alice to Bob. Does this have to do anything with the Byzantine generals problem, or is this a complete different topic?
No, this is quantum key distribution, and it's based on the principle of superposition. So I rushed through this a little bit so that we have some time. I should have taken more time to explain it. But basically what they're doing is, if they're transmitting the key from Alice to Bob, they're doing this with a qubit that is in superposition. So basically they encode that information, like the key they want to use, as multiple qubits, transmit this in superposition over to Bob. And the thing is, if you want to get the result, you need to look at it. We call this measuring. So you need to measure the particles. And this means the superposition state will collapse. It will come back to the normal state, if you will. And that's the principle that is being used here. Basically saying, okay, if someone looked at it, if someone measured it before me, I know that was not me, that was someone else that actually measured it. And so someone was trying to steal the key. And so it's physically impossible actually to eavesdrop, to inject or steal the information in between, because you will always know if someone measured it. You probably heard about Schrödinger's cat, pretty famous. It's the same principle in the end, right? If you don't know Schrödinger's cat, it's basically this kind of mind experiment. No real cats were hurt in these kind of things. It's just a kind of a mind experiment, if you will. You have a box. There's a cat inside of the box. You have a poison also inside of the box, and then you also have a radioactive element. The radioactive element will decay in 1 hour, and once the radioactive element is decayed, the poison will open up, and the cat, well, might get poisoned, right? And if you have this box in front of you, you will not know in what state it is currently. You have to open the box, and this is when you will measure it. So basically, the cat is in two states in parallel. It's dead and alive at the same time. And this is what you have with superposition. You know, you have multiple states at the same time. Again, crazy concept. It's very hard for humans to wrap our head around it. But it's the case. It was proven in experiments, and we can use this for computation these days, which is just crazy.
Cool. So we have questions in the chat. I saw something from Eugenio. Is it possible to have the metaverse slides? Thank you and congratulations for this talk. And then Oliver, in which blockchain tokens should I invest if I believe in the metaverse?
Well, that's a tough question. You might have, like, if we would have more time, I actually have also a section about metaverse economy and a couple of other pieces in there. Well, it's a tough question which one to invest on, because if you have followed the latest news there, the whole NFT place is not doing so well, and I guess we're entering the valley of the illusionment in the hype cycle a little bit here. So I'm not sure which one, but definitely Sandbox is doing pretty well. Sandbox is one of these decentralized platforms. The token is called Sand, and you can do some pretty interesting stuff with this. In fact, we're currently working with a client that wants to have, they call it, you can buy virtual land plots in it. And this client wants to establish like a branded experience in there, which is pretty interesting. Graphics looks like Minecraft with Sandbox, but it's an interesting experience. You will also find Warner Music in there. You can find also Snoop Dogg, for example, has a world in Sandbox. You can imagine what he's doing there all the time. But then I think The Walking Dead and so on. So a bunch of brands are entering these kind of spaces to buy virtual land plots and then, you know, establish certain experiences in there. And this is definitely interesting from a certain standpoint. But I would still say be cautious with it. It's of course a maybe overvalued market at the moment. I don't know, but definitely there's very good substantial pieces in it. But we have to disentangle the value from the hype there.
Yeah, this would have been my next question. There was some news about Decentraland and Sandbox, how many users there are.
Yeah.
And I had also some talks about this or some discussions on LinkedIn about this. But those people, they stated that there were 38 users on Decentraland.
Yeah.
Can you elaborate a little bit on that?
Yeah, I mean, it's like, I mean, look at Decentraland. Just go to Decentraland, look at the graphics. It looks like Second Life. The graphics quality, I mean, it's web-based, right? So I cut them some slack for being in the web, but still, I don't know, like the graphics, the whole experiences. If you visit the JP Morgan Onyx Bank, like there's not much you can do, and I think it's a little bit overhyped in that realm. But also to give Decentraland some credit, the company that actually did this analysis, the 38, what I found out, they have 48 daily users. You know what they did? They did actually quite a mistake there, and that's what Decentraland actually then corrected in a press statement, I think. Basically, what they've done with the 48 users, they were just looking at the blockchain transactions on the token that Decentraland is using, which means they have like maybe 48 transactions from 48 different users or wallets that are doing transactions every day on Decentraland. But it doesn't mean that they only have 48 users, because you can go to Decentraland, visit it, you know, engage with other people, do experiences without having to do any transaction on the blockchain, right? And so this was quite misleading. But, you know, typically these days, like it happens with the web, people like to throw dirt on other people, so it quickly caught up. But 48 users is definitely not true, actually.
Yeah, but this was published on a lot of publications worldwide, Fortune and so on. So it was completely a wrong calculation. It's a little bit like you say, you go to a football stadium and only count the people who have sold their ticket 3 times and not the people who sold their ticket 1 time. So you can go into Decentraland without registering on the blockchain, but you have to if you buy a piece of land in Decentraland, then you make blockchain transaction. So, but this was the thing.
Yeah.
But we have quite good numbers on metaverse usage, and this is, for example, on Metaverse. It's a platform where you see quite good numbers, and yes, Decentraland and Sandbox, they only have about 1 million users monthly, and daily numbers are not so usual. So monthly active users are 1 million. Okay,
Yeah,
but we have
that's
other. Yes,
that's not
go
bad
ahead.
actually. That's not actually bad. Like a few million monthly users. If you look at Zebeto, I had it on one of the slides. Zebeto is it comes from Korea, South Korea, and it's pretty popular in Asia. And it's basically an avatar platform. They have a lot of K-pop stuff in there, and it's interesting because the demographic are mainly young female users, and they are using the Zebeto platform. They have 20 million monthly users and are pretty active in the Asian market, and they're going to expand also into Europe and US and so on. And so they are going to grow quite a bit. But of course, if you look at Roblox, they have around 200 million monthly users. This is a different kind of a level, but it might be coming there. But again, you know, like you said, these decentralized platforms, it's pretty new and it's still pretty niche, but they already have millions of users, so it's not that bad actually.
Yeah, I have actually, and several hundred million unique users. Remember Facebook? I think they also only exceeded several hundred million unique users by 2009 or so. So we are already in a situation 2009 for the Web 2 when it comes to Web 3. So we are early, but not so early as some people think. So we have some more questions here. Eugenio, what is a single simple way to create virtual avatars filming a real person using a smartphone app, for example? First question from Eugenio.
Oh yeah, like you're saying, like a 3D capturing of a real person, or what is that?
I think so, yeah. Oh, Eugenio, if you can.
Yeah, maybe you can
Yes,
unmute.
yes. I mean some hardware kit to do some avatars, or for example to do some kind of film, 3D movies also. I see some company, some startup that has started with experimentation with very economic, very cheaper tools to do that. You know? In a way to have a copy of you in the like a virtual avatar, you know?
Gotcha. That's actually, let me share my screen again, and I can show you. That's actually what they did with Spatial IO, and you also have other platforms like Over, and I think Zebeto is also doing this. But basically, what you can do is you can upload a photograph of you, like a profile picture, and then there's some clever AI behind it that will do depth estimation and basically create an avatar that almost looks like you. But I'm a little bit torn apart if this actually is good or not, because again, let me share my screen again here with the slides with the Spatial IO demo, because they're basically doing this concept with Spatial IO here. Let me see, share the screen.
Over?
Yeah, like this. Okay, so if you look at this over here, this is basically what they're using. You upload a profile picture into Spatial IO, and they automatically create an avatar from you. But let me scroll a little bit where you can see the face. I mean, look at the face. It feels very uncanny, right? You know the uncanny value thing, I guess. And so this feels a lot uncanny. It looks almost like him, but it doesn't move the lips, and so it looks a little bit realistic, but it doesn't behave realistic. So your brain gets, it breaks in your brain the whole immersion, and it looks like you're talking to a zombie or a dead person. And that is very uncomfortable if you're in VR. So I'm not a big fan of this actually. And I would rather go either with very, very super realistic, hyper realistic implementations, or with things like, very comically based avatars, right? And so let me close this real quick. I have another deck here, because we're actually actively experimenting with this technology as well. So here you can see this, and this is a meta-human creator from Epic Games. They are doing Fortnite and Unreal and so on. And they have this MetaHuman creator. It's pretty amazing. It's web-based, so you can actually just search for MetaHuman creator. You can sign up for free and try to do that yourself. And you can create very hyper-realistic 3D character models and avatars. Here's a quick demo we did, for example, with a colleague of mine. It looks a little bit creepy because he's creating the Joker, but you know, we gotta have some fun at work, of course. And so he quickly creates the Joker here with some texturing and, you know, doing all the fun stuff with the hair, and is creating a very realistically looking avatar. And in the end, you can use an iPhone 14 with front-facing facial tracking, and you can see the real-time animation there, right? And we're actually working with a client here. This is a large bank. It's Intesa São Paulo, to create a web series for them. So basically what we used this kind of motion capturing, which again, you can do with an iPhone already, and can capture a character, and then we can create different avatars or different virtual personas for specific markets. So the bank is present in Egypt, the bank is present in Europe, and so you can have different cultural fits, but also you can repeat this quickly and don't have to record a new video for every market, but you can basically create these with these virtual or meta humans and digital humans. Here's another demo we did at our exchange. I know Ulf actually saw this for real, I think, like in real time at the conference. But here's what's the same thing. Like we had this kind of actress. So the actress there, a real actress, a real person, as you can see, she was wearing a bodysuit. So we can also animate the body, like you can see the hands movement and so on, and the face tracking again with an iPhone. And she's driving this real-time animation of an avatar, and they were having a conversation on stage. And after this was done, we had this kind of behind-the-scenes shot you can see here to show people how to do it. And so there's a lot of work in that space when it comes to getting to hyper-realistic avatars. But to be very honest, this will take many, many years until we actually have this at scale, so we can use it in these metaverse platforms. Because if you imagine, if you want to have this kind of a quality of an avatar like this here in one of these metaverse platforms, the rendering, like the computational requirements are immense. They're very, very huge. In order to render just one single character, you need a powerful graphics card. And if you want to do this in a world where you have hundreds of these characters, we might need quantum computing for this.
Awesome, yeah, and I really must say, when I was seeing this at Reply Exchange in Munich in June, that was awesome. The real conversation, and as far as I recall, also your CEO from Reply, he was talking in another language to the girl, so it was simultaneously translated from Chinese to English, I think so, and this was awesome to see the real Babelfish from Hitchhiker's Guide to the Galaxy come to fruition. This is awesome, great.
I mean, we're all nerds, right? You can imagine where we get the inspiration from. So yeah, Babelfish.
Yeah, exactly. So another question from Eugenio. You want to ask the question yourself? I would also have some remarks.
Yes, I can ask very, very fast. I know too many questions from me, but it's very interesting. Can you explain better the interoperability protocol to connect different metaverses? Because it seems very impossible, because every metaverse has rules, rendering, different rendering. It seems impossible.
Yeah. So here's I stopped sharing. I have another slide here which can explain this a little bit. So this is NVIDIA's Omniverse, which is they also call it a metaverse platform. And it's actually one of those very few where you can say, wow, this is really entering production scenarios and adding a lot of value in the enterprise, and especially in certain worlds like manufacturing, product design, and so on. And what they are using is, so basically with the Omniverse platform, if you take this as a prototype of an interoperability, a metaverse, which is going to happen, hopefully, they are using USD, which is a format that actually comes from Pixar originally, but it's a thing called Universal Scene Description. And it's an also streamable format, a 3D model format in the end. where you can transmit 3D models and 3D information between different platforms. And with Omniverse, for example, you can use 3D modeling tools like Maya, 3ds Max, Cinema 4D, like these are some 3D modeling tools, but then also simulations like physics simulation engines or building information management systems like Revit from Autodesk and a few others. And all of these also have the same challenge. They use their own proprietary file formats, their own proprietary 3D model formats. But if they build connectors where they can stream it real time via USD, you can plug those together. And this is the basis. And this is also where the Metaverse Standards Forum is going into a direction at the moment is let's use USD as a ground level, right? And of course, like the rendering will look a little bit different, but as long as you have the same kind of model format description that also includes shaders and how the shading should look like, the textures and all of this stuff, you can get this interoperability. So it's basically, you can think about the USD format could be the HTML of the metaverse.
Yeah.
Thank you. Now it's clear. It's more clear. Thank you.
And I think also, I don't know whether you completely mentioned it today, but isn't it so that Microsoft and Meta have agreed on a interoperability standard just last week?
They did not agree on interoperability standard, but they announced a partnership basically where they were saying, hey, we're going to bring our mesh platform into Teams. But you're right, actually. You know what they said is we're also allowing to use Meta avatars inside of the Teams avatars. So you can use your Meta avatar together with your Teams avatar. And that's also pretty impressive. And hopefully they're going to pull this off. Because here's another slide. Again, I didn't show this today, but this is myself as an avatar in 3 different platforms. Meta, Horizon, second is Altspace, and then the third one is Snap. And that's all my avatar, and it all looks different, which is a big challenge. And this is also where I see huge potential actually for decentralized identity, blockchain-based systems. For example, your avatar could be actually an NFT, right? And so I would be able to, okay, this is Rene's avatar, and it doesn't matter if it's platform from Meta or platform from Microsoft or platform from Google or Apple or whatever. And they can exchange these formats together. They know a common standards like USD. And then also, if I can use my decentralized identity, I can use my wallet, my unique key to actually identify in the system. And then also I have an NFT connected to my avatar on that system. So it's always sure that that's me. This is also a very important aspect if we think about security and privacy aspects of it, which we haven't talked about at all, but a very important piece of the whole equation when we're talking about metaverse, because the regulation in that space, there's no regulation at the moment, and so I can impersonate anyone, right? Like I can design an avatar that looks like a person, and then I can just create a fake username, and then I can do some pretty bad things. And if you look at the platform VR chat, just Google VR chat harassment, you will find some pretty bad stuff that is happening in there. And this needs to be solved, and we need certain regulations there, and we need also, that we are sure that the identity is actually maintained across these different platforms. And I think this is really a big opportunity for blockchain-based decentralized identity systems.
Yeah, awesome. So I would have another question on quantum computing. So what is you a little bit already outlined it, and set a time horizon between 5 and 30 years. But what is your take on this? And just to a little bit go back on why I'm asking this question, we will have another talk in some weeks with Mike Dowling on business applications for quantum computing. And I think that the question is, when will this happen? Is very, very important for us. So you gave a little bit of an outlook, but if you can again.
So business applications with quantum computing. I mentioned the other slides here, which which I've shown here, the for Enel, where this energy grid provider, this is in production already. And so you can have certain specific problems already solved with quantum computing, but this is quantum-inspired optimization, which means we design and develop an algorithm that is based on quantum computing ideas, which means you develop your algorithms way differently because we're dealing with a non-deterministic system. So you program these quantum computers with gates and circuits and so on. And if you write your quantum algorithm for the optimization in such a way, like it's called megacubo, which is quadratic unconstrained binary optimization, way too much details here, but if you can formulate a problem in a quantum mode, you can already run this on quantum simulators. So we're using graphics processors, like a huge array, of course, in the cloud, and you can run this quantum algorithm, and it simulates under the hood how a quantum computer would behave. And already with the simulation, we're getting 20% time saving for 20,000 field service workers that have to go out every day. And so we can optimal plan the route for them, and they don't waste so much time on the road. And this is, again, a huge time saving. If you think just at the cost, 20,000 people, 20% less time, it's huge. And this is just on a simulator with a quantum algorithm on a quantum simulator. Now think about, once we have powerful enough quantum computers, we can take this algorithm as it is, run it on a quantum computer, and we'll just fly. So this is already use cases we can develop today, even with these very small quantum computers we have. The biggest one that is currently available is from IBM. It has 127 qubits. But IBM also announced that they're going to release a quantum computer this or next year, which should have around 433, I think, qubits.
Wow.
And if we come back to this slide, well, look at this. 4,099 stable qubits are required to crack or break RSA 204080 in 10 seconds. And when this happens, I don't know. It might happen in 30 years. Experts, again, there's a paper from real science experts, and they say 5 to 40 years is their estimation until we will have these powerful quantum computers. You know, people sometimes call it quantum supremacy, but it's not a good word. So it's better to say quantum advantage, right? When we have the quantum advantage, and this we'll see how long it takes, 5 to 40 years. I'm rather would say it's in the lower end of that range, because sometimes in technology breakthroughs happen exponentially, and it might happen pretty fast. And that's a threat, and a lot of people don't realize that this is coming, and that folks need to be prepared for it. But the good news is there is actually also research for quantum resilient cryptography algorithms. The NIST, the US National Institute for Standards, they have a post-quantum cryptography challenge, and they actually already, a bunch of very smart mathematics people developed quantum resilient or post-quantum cryptography algorithms. The challenge at the moment is they're not very performant, and also think about basically on all servers, on all smartphones, all of there, you need to swap out the encryption algorithms. And this will take many years. And that's the threat we're basically facing, is like, how long will this take? And that's why I said, for companies, it's very important to be very agile with DevSecOps and crypto agility, to be able to quickly change and swap out these kind of quantum resilient encryption algorithms, to swap out the old encryption algorithms to these new ones. And well, if you look at the budgets that are invested by all the big governments, the US, Europe, and China are pretty much leading when it comes to investing in quantum computing research. And especially China is quite ahead. And like I said, they already have a satellite up there which can do quantum key distribution. And the US also heavily investing in this. And of course, the DARPA very much interested in all of this stuff. The NATO as well, they just announced another research center, I think it was in Denmark or somewhere, for quantum computing. And so all of these are very much actively working on it. And they're probably not going to tell us once they have it, they will just use it. So
absolutely. There are big companies going on it, IBM, Google, and so on. So we have one question referring to something you said about the 400 qubit. Wolfgang, can you elaborate on that? Or you mentioned that the IBM qubit are noise qubits. Is that correct, Wolfgang?
Yeah, sorry, just what Rene just mentioned, that IBM announced they will have a quantum computer with 400-something qubits next year. This will be noisy qubits, not the stable qubits, right?
Oh yeah, very good point. Very good point. Yes, exactly. So we're not getting close to 4,000 very soon. To be very clear. Thank you for pointing this out. Very good question. So when we're talking about, let me just expand on this a moment. So noisy qubits are these physical qubits basically, but in order to have a stable qubit, or we also say logical qubit, you need many more physical qubits, because they are very prone to errors, right? Like keeping such a qubit in a superposition state requires a lot of things you need to do. First of all, these quantum computers are typically like where they keep these qubits are in a vacuum, and they're typically also close to 0 Kelvin, so very cold, so as cold as it is in the universe basically. And only then you can keep a superposition state, and only for a few nanoseconds at the moment. And of course the big research is going to do this much longer. And then also you need a bunch of noisy qubits actually to do error correction, because you have a bunch of errors, and so you actually need multiple hundreds of thousands of qubits to make actually one logical qubit or one stable qubit. And so this will take a little while until we're there, but again, true experts say 5 to 40 years. So that's the prediction.
Okay, we have 3 more questions and only 10 minutes time. So I would take first Eugenia's question because it refers a little bit to it. It was also, Reinhard, then post the question on energy usage. Yes.
Yeah, let me just connect to the question of algorithms. So yes, there is explain security and the traveling salesman problem, where we have very successful categories of algorithms which we can solve much quicker, or we can solve it all with quantum computing. But to connect to the metaverse, I don't understand yet, because here we are, what are we talking, computer graphics and so on. So what kind of problems and algorithms are there that you consider to be solved much faster with quantum computing?
Yeah. Well, that's the kind of connection to the metaverse is, like I was saying, we need to run a lot of simulations. Like think about these large metaverse world where I need to simulate multiple things at the same time, like multiple states. And these quantum computers are very good at keeping these kind of non-deterministic, but also keeping multiple states in parallel and computing in parallel. So that's why I could see a use case for this. But actually, true use cases for quantum computing are not so much the metaverse. I have to, of course, admit the most important ones are very NP complex problems, very time consuming and resource constrained problems. So think about, like I said, protein folding and drug discovery is a very interesting piece. Although certain AI like from OpenAI and DeepMind and so on, they're also working on AlphaFold and this kind of stuff, where they're already achieving ridiculous breakthroughs already. Like protein folding, what is this? So basically in chemistry or certain life sciences, they need to estimate basically how these molecule chains and proteins, which are huge molecules, basically how they behave, how they change. And all of this is 3-dimensional, and you have thousands or millions of molecules, whatever, in these very complex ones. And how they will fold, how they will behave is a super hard, complex problem to solve. And this you can, for example, do with quantum computers. Where they're also applying it already is for fertilizers, like finding out new kind of chemical formulas for fertilizers and optimizing these things. But also, if you're asking for the energy consumption, surely these quantum computers take a lot of energy, just to cool them down, keep them in the vacuum, all of that stuff, which is, if you're thinking about sustainability and sustainable cloud efforts, probably you might say, oh wow, this is wasting a lot of energy and it's burning a lot of money and CO2 emissions and whatnot. But in the end, it might actually help us to solve the big problems, and like climate modeling. Like climate modeling is also one of these super complex problems where you can probably take advantage with quantum computers, where we can simulate these climate models to a higher degree with more multiple states at the same time and so on. And so I think it is an investment, but in the long term, it might actually be required to solve the big problems we are facing as a humanity.
Fabrice, I've got a question.
Yeah, thanks a lot. I also have a question to the safety on quantum computing, because from a financial perspective, because if quantum computing becomes more established, how easy is it to decrypt existing blockchain cryptocurrencies? So at the end, maybe all the existing ones at the moment become worthless in few years, just because quantum computing is accessible for a lot of more users.
Yeah, very good question. Might be the case, in fact. We'll see. But the example I gave with breaking RSA 204080, and this is based on an algorithm that is called Shor's algorithm. This is from Peter Shor. He invented the quantum algorithm, I think in the 90s or so. Super crazy mathematician, right? Like, but this is already implemented. And what Shor's algorithm does, it does a thing called prime factorization, prime number factorization, because these encryption algorithms like RSA or asymmetric encryption or public-private key encryption, they are based on prime numbers typically, which are very hard to reverse engineer to, prime factorization. But if you're applying Shor's algorithm with a quantum computer, again, using quantum computer, doing all of this in parallel, you can quickly do this prime factorization, prime number factorization. And so this is for RSA. Blockchains typically don't use RSA, they use elliptic curve cryptography, which is a different kind of cryptography algorithm. But it's very likely that you can adapt Shor's algorithm. You might not use exactly Shor's algorithm, but you can get an adapted version or a modified version of this. And you can imagine a lot of folks are working on this. And this will also allow you to crack elliptic curve. We'll see. But yeah, we should know the right time when it's the right time to sell all the coins, I guess.
Yes. Okay, thank you.
That's the $1 billion question.
I would have a last question on a little bit back to spatial and to augmented reality. And my question would be, you said that these glasses and these Oculus Quests, they are not really usable. Will there be an AR glass in the future, or what do you think will be the future of these devices when it comes to it?
Well, I also have a HoloLens here, which, I'm using my fancy Kinect camera here for the presentation, so it's probably not catching it very well because it has all black stuff, so you cannot probably see it very good here. But I'm sure you have seen these devices before. Great device with augmented reality capabilities, or Microsoft calls it mixed reality. I'm bullish on these kind of devices, but this is way too big, and this needs to be solved. And so in order to have acceptable form factor for head-mounted devices or AR glasses, they need to be this kind of a size, right? And that's a big challenge to shrink it down in terms of the form factor, because the whole optic stack is very complex. They're actually hitting physical limitations already, and there's core research or deep tech research, if you will, in terms for the optics, so that you can have displays where you can have them small enough so they would fit into normal glasses, but then you also need sensors to actually understand the environment. And putting a bunch of cameras is probably not going to be socially acceptable. We all know the Google Glass, the glass holes, right? And so that's not something that is going to be repeated. So I think AI, computer vision, and maybe also sound, and analyzing the scenes with so-called beamforming microphones is probably going to be working in that space. But in the meantime, what we see is with the Meta Quest Pro. Also, there's another device that is currently coming out, the Pico Neo 4, which hopefully I get tomorrow at my door, and a Lenovo one. These are all virtual reality devices, but what they're doing is they're not just providing the whole immersion. They could put on this device, which means you don't see the outside world anymore, but they have newer cameras, and they even have color cameras. And so the Quest Pro can provide you the outside view via the cameras, and they even do stereo 3D, so you can see basically on these displays the real world around you, the physical world, and then on top the virtual elements. And I think until these optics constraints, like with the HoloLens and so on, these are being solved, I think these kind of devices like the Meta Quest Pro, which are providing these so-called a pass-through augmented reality mode, will be probably the most promising for the next few years. And if the rumors are right, this is probably also going to be the approach that Apple is taking with their headset. And so I would say we're still in the beginning. It will take a few more years actually to get there, that these are small enough form factor for affordable price with social acceptance. This will take maybe this decade, and but it's getting there. This will be the new mobile form factor, spatial computing, head-mounted devices.
Awesome. Thank you so much, Rene, for your talk. It was amazing. It was mind-blowing, and it was really very interesting overall. And thank you so much. And good evening for everybody.
Thanks for having me. Bye-bye.